Hi guys, welcome back to my channel. Today we're going to be looking at the dot product of vectors. So we have to be really careful when we're dealing with this because there are two different ways that we can do multiplication of vectors. So the first way with the dot product, we actually end up with a scalar value, so a single value output. And the reason that we might calculate something like this is for two reasons. The first reason is that the dot product of two vectors could be equal to 0 when the vectors are perpendicular to one another. So in other words, when the vectors are at right angles to one another. The other reason that we may choose to find the dot product is because we're looking for a particular length or a particular value, so a single value output. So let's have a go here. We've got the dot product. We want to find the dot product of two vectors where A is equal to 3i plus 3j and B is equal to 6i plus 2j. So the reason I have two different formulas is because it's going to depend on whether or not you are using polar form or Cartesian form. So this equation here, where we've got the magnitude and we've got the angle, is going to be for when we are using polar form. And here when we have the components, that's when we are going to be using the Cartesian form. So with my two vectors, I'm going to go ahead and convert those into polar form to show you how we can use this first equation. Now I've got my two values in polar form. Let's go ahead and let's draw each of these so that we can determine the angle between the two. So we know that this angle in here is going to be 45 degrees, and we know that this angle in here is going to be 18.43 degrees. And so this angle in here between the two vectors is going to be the difference. Now we know the magnitude of each of our vectors and our angle, we can go ahead and substitute back into our original formula. So the dot product of A and B is going to be equal to the magnitude of A times the magnitude of B times cos theta. So that's going to be equal to 3 root 2 times 2 root 10 times cos of 26.56 degrees. So our dot product is going to be 24. So what if we wanted to do this using Cartesian form? Well, for us, because our question was originally in a form that was easy to convert to Cartesian formed, the other equation would have actually been the better choice here. So let's go ahead and write that formula. So the dot product of my two vectors is going to be equal to the multiple of the x components plus the multiple of the y components. So originally for my first vector we had 3, 3, and then for my second vector I had 6, 2. So for my x component here, this is going to be 3 times 6 plus 3 times 2 for my y component. So that's going to be 18 plus 6, which again is going to be 24. So depending on which form that we originally have it in will depend on which formula we choose to use for our equation. So that's how we find the dot product of two vectors and how we can find it in both polar form and Cartesian form. Alright guys, I'll see you in the next video.